Hello, this is Manjula, lecturer in electrical, Government Polytechnic, Secunderabad. So today's session is about the classifications of the DC motor and the problems on EMF. So after completion of this period, you would be able to know the classifications of the DC motors and the formulas for back EMF for a different DC motors. So what are the different DC motors available? So we know the generators, what are the different generators are available. Likewise, there are different DC motors. We'll see what are the different DC motors. So the DC motors are classified according to the way in which their field is excited. So the DC motors are classified as separately excited DC motor and self-excited DC motor. In self-excited DC motor, there are three DC motors, that is series motor, shunt motor and compound motor. In compound motor, another two will be available, that is short shunt compound motor and the long shunt compound motor. So these classifications are similar to that of the DC generators. If we observe, so first we will see what is a separately excited DC motor. Okay, these motors have field coils similar to the field coils of the shunt wound motor. So the field coils will be similar to that of the shunt field winding motor. So the field coils are excited by the separate DC motors. So armature current IA is equals to I, which is equals to line current, and the back EMF generated, that is EB, is equals to the applied voltage minus IaRa. Once we'll see the circuit diagram. So this is the circuit diagram. So this is same as that of the shunt field winding, and which is excited separately by some voltage source. And also here, as this is a motor, we have to give supply to the armature and also field. So here we are giving field with a separate voltage, and also we need to give the voltage to the armature, because this is a motor, so it will take the power and the output will be the mechanical output rotation. Okay, so here this voltage and this voltages are separate, so hence it is called separately excited, as we are exciting the field coil separately with another source. Okay, so if you observe, this is a ISH current, this is an RSH, and the current from here it will come, so the load current will be the armature current, and this is RA, so there will be a drop IaRa, and this is a EB, the voltage generated, the back EMF generated. Okay, so this is a separately excited DC motor circuit diagram. So in DC series motor, so this is a self-excited, one type of self-excited DC motor. So the field coils consist of very few turns, of thick wire, and are connected in series with the armature. The field coils have low resistance. When compared to shunt field winding, the field resistance of the series motor is very less. The cross-sectional area of the wire used for field coils has to be fairly large to carry the armature current. So, the series motor field winding features will be in such a way that it will have very small and few turns of very thick wire, and the cross-sectional area is large. Hence, the resistance will be low. Okay. Fine. The armature current IA is equals to the series field current ISC, which is also the load current. We will see in the circuit diagram. Okay. So this is the circuit diagram. So here the series field RSC and the armature RA, EV, and this is an IA current, armature current. So when we give supply to the DC series motor, first you will get a line current. Line current here, as it is going through the series field winding, so IL is equals to ISC, and the same current is flowing through the armature, so ISC is equals to IL. So here IL is equals to ISC is equals to IA because all are in series connected. Okay. Now shunt motor. We'll see the DC shunt motor. The word shunt means parallel, as we know already. Okay. So the field coils are connected in parallel with the armature, and the field coils consist of large number of turns. So there is a difference between the shunt motor and the series motor coils. Okay, that we have to observe with the constructional difference, that there it is a very small few turns of coil. Here it will be the large number of turns, and this resistance will be very high resistance, shunt field resistance. This is a current equation. I is equals to IA plus ISH. I is nothing but IL, load current. The shunt field current ISH is equals to V divided by RSH. This formula we have already seen in DC shunt generator. And V is an applied voltage. RSH is a shunt field resistance. And the back EMF formula EV is equals to V minus IA RA. So we'll see the circuit diagram. So this is the DC shunt motor circuit diagram. So here we are applying the voltage V, and if we observe there is a shunt field winding across the armature. So this is called a shunt or else parallel. So here that is what we are calling it as shunt motor. So here the load current will split to the armature and also to the shunt. So here this is an IA and this is ISH. So hence the total current, that is IL is equals to IA plus ISH. So the next motor is DC compound motor. So DC compound motor, it is a combination of both the shunt and series field coils. So the shunt field is normally the stronger of the two, that is has more ampere turns. DC compound motor has two types. The first one is long shunt DC compound motor and the second one is short shunt DC compound motor. Long shunt DC compound motor, the shunt field winding is in parallel the shunt field winding is in parallel with both the armature and series field winding as shown in the figure. We'll see the figure. So ISH is equals to V by RSH and IA is equals to ISC is equals to IL minus ISH, and EB is equals to V minus IA into RA plus ISC. We'll see how these formulas have come. Okay, so this is a long shunt compound generator. We have two types, that is short shunt compound generator and long shunt compound generator. This is a long shunt compound generator. We have applied the voltage here to the armature, and the armature has a series field winding and also it has a shunt field winding. Here this winding is across the series field winding and armature field winding, hence it is called a long shunt compound motor. Okay, so here the current IL will split to the ISC and also the ISH. Okay, so this is the current which is flowing through the series field winding, hence it is an ISC, and the current IA which is flowing through the armature. So this is EB, and the internal resistance RA and the internal resistance RSH. Okay. So here the formula ISH is equals to V by RSH and IA is equals to ISC is equals to the load current minus ISH. Okay, that is because, so here the IL, if we want ISH, then the current IL minus ISC or IA. Okay. So here the total current IL is equals to ISC plus ISH plus ISC or ISH plus IA, as IA and ISC both are equal. And the back EMF EB, which is equals to the voltage applied minus the drop across the armature and also the resistance. Okay, so V minus drop across the series field winding and the drop across the armature. Okay, that is the EB, that is back EMF generator. So we'll see the short shunt compound DC generator. Here, the short shunt winding is in parallel with the armature along, and the combination is in series with the series field winding. Okay, so this we will see. Before that, we'll see the circuit here. So these are the circuit. See here, if we observe the shunt winding is in parallel only to the armature. Okay, so it is not in parallel to the series field winding. So hence this is a shorted. So hence it is called as a short shunt DC motor. Here if we observe, what will be the total IL current, load current? So the IL is equal to ISC because the IL is flowing through series field winding also. So here IL is ISC. Now the IL is equals to IA plus ISH. Okay. So IA is equals to the armature current, IA is equals to the total current IL minus ISH. Yes. And ISH is equals to V minus ISC RSC divided by RSH. Okay. So that means here V minus this drop divided by RSH will be the ISH. Okay. So ISH will be V minus the drop of this drop at the series field winding divided by RSH is ISH. Okay. Now the EB. EB will be EB is equals to V minus ISC RSC minus IARB. Okay. This minus and this. So here the currents are different. So we are taking as it is. So here now we will see the problems on back EMF. We have got some of the formulas according to the excitation in voltage forms. Okay, that is back EMF formulas and the current equation formulas. Back EMF voltage equation formulas we have got, and we know already that the back EMF according to the generator action, that EB is equals to pi z n t by 60A. We know even that formula. Even if it is necessary, that formula of usage, we have to analyze the problem first. Once we have to read the problem, we need to analyze the problem. Then we have to cross check that which back EMF formula will be suitable according to the given data. By that, we have to choose a formula. Okay, fine. We'll see. This is the first problem on the back EMF equation. So here, the power input to a 230 volts DC shunt motor is 8.477 kilowatts. And the field resistance is 230 ohms. And The armature resistance is 0.28 ohms. Find the input current and armature current and back EMF. So here the power input has been given, the voltage V has been given, and RSH 230 given, RA 0.28 given, and what we need to find out is IL, IA, and EV. Okay, so the given data. So these are the given data, information, and the problem solution. So we know that the power is equals to 8.477 kilowatts. So into 1000. Okay, divided by V. So power is equals to VL into IL formula. So we are here finding out the IL. So IL is equals to P divided by V, which is equals to 8.477 into 1000 divided by 230. Then we will get that IL is 36.86 amps. Then shunt field current, ISH. ISH is equals to V divided by RSH. So which is equals to 230 divided by 230, that is 1 amp. So 1 amp is a shunt field current. So armature current. So armature current IA is equals to IL minus ISH, which is equals to 36, 36.86 minus 1, which is equals to 35.86 amps. Okay. So actually when we are solving any problem, it is better to draw the circuit diagram so that immediately you will get the formulas, you will remind the formulas. Okay. So here I am drawing this is a shunt motor, right? So this is an applied voltage V. So this is an IL. The current which is flowing through the armature is IA. And the current which is flowing through the RSH, that is shunt field winding, is ISH. This is the back EMF EB. Okay. So here IA is equals to IL minus ISH. Okay. So hence this IA will be 35.86 amps. Now we need to find out the back EMF EB. So EB is equals to V minus IARA. Okay. So we know that V applied voltage is 230 minus IA is 35.86 into RA is 0.28, which is equals to 219.96. So the EB generated, the back EMF which is developed is 219.96. Okay, 219.96 volts. So you have to remember one thing. See, always the EB will be less than the applied voltage in a motor, and the generator is that EG. So there we will call it as EG. So EG will be always greater than V. Okay, but EB will be always less than V. This is a logical hint that it will give an idea for you if you remember this. Okay, yeah. And the second problem, we go to the second problem, that a 230 volts DC series motor is, here it is a series motor. Okay, So 230 volts DC series motor is taking 50 amps. So, once again, okay, now we will see the second problem, that a 230 volts DC series motor. So here we are taking a series motor. Before that we have done a shunt motor problem. Okay. So series motor which is taking 50 amps and the resistance of the armature and the series field winding is 0.2 ohms and 0.1 ohm respectively. Then calculate back EMF, power wasted in armature, gross mechanical power developed. Okay. So here they are asking the 3 points. We know the back EMF formula. So yes, we will see even the power formula at armature and the gross power developed. Okay. So according to the given data, the voltage V is 230 volts, IL is 50 amps, RA is 0.2 ohms and RSC is 0.1 ohm. Here you have to analyze one point, that see RSH will be always, that is the shunt field resistance will be always large and series field resistance will be always in small quantity. If you check here, it is 0.1 ohm. Okay. And the back EMF formula, according to the circuit, we have already seen that EB is equals to V minus IA into RA plus RSC. Okay. Because ISC and RSC both are same in series field winding. So substitute in the formula that 230 minus 10, I mean 50, that is IL. Okay. So IL will be IA here, IA will be ISC also because all are in series. So 50 into 0.1 plus 0.2. So that will be 215 volts. So now we got the back EMF voltage. Now the power wasted in armature. So the power wasted in armature is IE square RA. So IA is nothing but 50. So 50 square into RA 0.2, that is 500 watts. And the power developed, mechanical power developed, PM is equals to EB into IA. So we know the EB, that is 215 into IA is 50. Okay. So 215 into 50, which is equals to 1075 watts. That is 1.075 kilowatts. Okay. So this is about the formula, and see, remember that always you have to draw the circuit diagram. Okay, which is a good habit, so that you will get the equations immediately after seeing a series motor. It is no need of buttifying. Okay, so you will get the equations immediately with the circuit. Otherwise, always the circuit should be in your mind. Remember that point. Okay. Now we will go for the another problem. That is a third problem. We'll see what is this. A 6-pole lap wound DC shunt motor has 500 conductors in the armature, and the resistance of armature is 0.05 ohms, and the resistance of shunt field is 25 ohms. Find the speed of the motor when it takes 120 amps from DC mains of 100 volt supply. Then flux per pole is 2 into 10 to the power of minus 2 Webers. Okay, so this is a all given part, and we have to find out the speed. Okay, so for this, yes, once when we go through the problem, we have to analyze which formula will be suitable according to the given information. Okay, so here if we observe, we have to use the two formulas, that is EB is equals to V minus IARA and EB is equals to pi z 10 P by 16A. Okay, so first we will write a given data. So the given data, that is a lap winding, so the number of parallel paths will be equal to the number of poles. So A is equals to P is equals to 6 poles, and Z is a 500 conductors, RA is 0.05 ohms and RSH is 25 ohms. and IL is 120 amps, V is 100 volts, pi is 2 into 10 to the power of minus 2 webers. So we'll see the problem now. So ISH is equals to V by RSH. Shall we draw a diagram? Better we'll draw a diagram. So it will be easy for us. So always you have to draw the diagram for each and every problem. Which will make you a habit that not to verify any formula directly. You will get the formulas from the circuit diagram only. As this is a generator, the current direction will be this side. I mean, it is a motor, the current direction will be towards the armature, otherwise it will be away from the armature. Okay, we know that already. Okay. So ISH will be is equals to V divided by RSH, that is 100 divided by 25, which is equals to 4 amps. Okay. So IA is equals to IL minus ISH. IA is equals to IL minus ISH. So 120 minus 4 is equals to 116 amps. Then EB formula also we know that EB is equals to V minus IA RA. So we know V, IA and RA also. So directly we can substitute the values, which is equals to 100 minus 116 into 0.05, which is equals to 94.2 volts. So the speed of the motor. So the speed of the motor, we can directly get it from the formula that EB is equals to pi Z10 by 68. So from that, N is equals to EB into 60A by pi ZP. So substitute the values. These all values is available with us. So substitute EB is equals to 94.2 into 60 into A is 6 and P is 6, Z is 500 and pi is 2 into 10 to the power of minus 2. Then now we will get the speed. So the speed is 565 RPM, that is revolutions per minute. So the speed of the given DC shunt motor and with all the given information, speed is equals to the 565 RPM. Okay. Hope so. Today we have discussed about the back EMF and the circuit diagrams, the back EMF formulas and the problems on the back EMF equations. That is according to the generator principle and also according to the circuit diagram. uh, we know some of the back EMF equations and also the current equations. So by using the equations, we have solved even the problems. Hope this session is understood for you. So we'll meet in the next session. Thank you.